For the beginning part of this lesson, I'm going to revise and recap the vocabulary the children have been using with fractions. And then I'm going to give them a decimal number. I'm going to put it on the blackboard, 1.1111, reoccurring. With this number, I want the children to use what fraction knowledge they know and try and guess or approximate what fraction it will be. These are our objectives of this lesson today, and by the end of this lesson I'm hoping that all of you will be able to do this. Let's have a look at them. Change fractions into their decimal equivalent. Does anyone know what that means? Changing fractions into their decimal equivalent. We know what the word equivalent means, don't we? Go on then, Amy.
Make a fraction into a decimal, which is equal.
Well done, you've said that really well. Well, I'm going to show you how to do that today, but today I'm going to teach you how to do it by using the calculator, because we're going to be using the OHP today. Also, the second thing we're going to do today is we're going to look at recurring numbers. What's a recurring number? Does anyone remember what a recurring number is? Emma?
It goes on and on after it, but it doesn't really mean anything.
Now, has anyone seen a number like this on a calculator? Look at this number. Who can say it for me? Adele?
1.111111.
Well done, Adele. What is the number just before the decimal point? Claire?
1.
1. If I'm explaining to you now that you've got to turn this into a fraction, you're going to find the equivalent fraction of this decimal number. What sort of a fraction is it going to be? Because we've got more than the whole there. Keely?
Improper fraction.
Oh, what, sorry?
Improper fraction.
Improper fraction. Who can tell me what an improper fraction is? Emma?
Numerator is bigger than denominator.
The numerator is bigger than denominator. Well, you're right, it is an improper fraction, and the numerator is bigger than the denominator. Right, 0.11111. Does anyone know any decimal numbers near 0.1111? Does anyone know what a half is as a decimal? Adele?
0.5.
Right, brilliant. A half is 0.5. Is that number less than or small or bigger than 0.5? What do you think, Stuart?
0.5 is bigger than 0.11111.
OK, so it's not a half. It's got to be smaller than a half. Who can think of a fraction that's going to be smaller than a half? Can you think of one, Dalip?
A quarter.
A quarter. Do you know what a quarter is as a decimal?
1.
A quarter.
Point.
0.25. Well done, 0.25. Excellent. Who can think of a fraction smaller than that? Because 0.25 is too big for that. Mandy?
An 8.
An 8. Do you know what an eighth is as a decimal?
0.125.
Is 0.125 bigger or smaller than that? Amy?
0.125 is bigger.
It is. So it's got to be, this fraction's got to be smaller than an eighth. I wonder if we can think of a fraction it's got to be bigger than. Ross?
A tenth.
A tenth. Do you know what a tenth is as a decimal? James, you help him out.
0.1.
0.1, yes, well done. So is this bigger than 0.1? If you could just imagine it on your number line, would it be bigger or smaller than that? Claire?
Bigger.
That's bigger?
Yeah.
Yeah, brilliant. OK, so it's bigger than a tenth, but smaller than a eighth. Oh, I wonder what fraction we can think of that's bigger than a tenth and smaller than an eighth. Sarah?
A 9.
Is she right?
Yeah.
Well done, Sarah. Yes, a ninth. I felt my lesson went really well. I was really pleased with the children at the beginning of the lesson because obviously they'd used their knowledge from previous lessons. Emma?
Numerator is bigger than denominator.
The numerator is bigger than denominator. Well, you're right, it is. For the main part of my lesson, my two objectives are, first of all, to teach the children how to use a calculator to find the decimal equivalent of fractions, and also to recognise that to place recurring numbers on a number line, they need to round them up. Then I'm going to give the children 3 activities depending on their ability. The first group, I'd like them to place different fractions on a number line. First of all, working out on a calculator what the decimal equivalent is, and then place this on a number line and try to beat one another by getting 3 crosses on a line consecutively. The second group will be doing the same activity but slightly harder because they'll be able to use any digits that they want to. And finally, the third group are going to be using a number line from 0 to 2, which means that they'll go into using improper fractions. And I'm going to help you, I'm going to teach you how to use a calculator to work out the decimal equivalent of a fraction. So get your calculators out. OK, who can tell me what a half is as a decimal? Mandy?
Is it 0.5?
It is 0.5. Who can tell me another way of saying a half? James?
1/2.
Or
1 divided by 2.
1 divided by 2. Now, and I'm going to type it in on my calculator, and you can do it on yours. See what happens. 1 divided by 2, pressing the equals. What does it give us on our calculators? My calculator as well. David?
0.5.
0.5. And we can use this method to work out lots of other decimals. Let's try it out. Think about a quarter. What will we have to think about another way of saying a quarter? Michelle, do you know?
1 divided by the 4.
1 divided by the 4. Right, let's try it. 1 divided by 4 equals... And what does it say on your display, Gemma?
0.25.
0.25, is that what yours says? Yeah. Brilliant. OK, let's try a bit harder now. Let's get a bit harder. Go on then, Claire, you think of one.
16.
16. So what do I have to key in? Mandy.
Is it 1 divided by 16?
Is it? Yeah. OK, let's type it in. 1 divided by 16 equals...
0.0625.
Excellent. Well done, Sarah. That's just right. What was the decimal number I gave you? What was the decimal number I gave you? Adam?
1.1111.
Excellent. And what was the fraction we worked that out to be? We said it was an improper fraction, and we said the 0.1111 was worth 1/9. So what must the whole number be worth? 1 whole number. How many ninths will make a whole? Gemma?
9.
9 ninths will make a whole. Add on our 1/9. So how many ninths have we got altogether?
10.
10 ninths. Well done, 10 ninths. So let's key that into our calculator to check our answer is right. What do we have to key in? Sarah?
10 divided by 9.
Is she right? Yes. Go on then, let's try. 10 divided by 9 equals... And the answer is... Stuart?
1.111111.
Excellent. OK, Adam, what's the first fraction you're going to start with?
Half.
A half. All right, well, key it into the calculator. Do you need to key it into the calculator? Do you know what a half is as a decimal?
Yeah.
What is it?
0.5.
So where's that going to appear on your number line? There. What did you choose there?
It's in the middle.
It's in the middle. And what do you know about half? It's in the middle. It's halfway. OK, well, you put your cross. You'll have to think of a special symbol for you, won't you?
I'll go for 3/10. I'll do 2 ninths. It's around about there. I'll go for 3 ninths. So that's somewhere around about that end. I'll do something smaller.
Right, OK, Adele, which way are you going to go? You want to do a quarter. What is it as a decimal?
0.25.
OK, where's that going to appear on your number line?
Is it about there?
About there. Why about there?
5 divided by 6. 0.83333.
That goes in between there. Yeah.
Should be going here. Because
Yeah.
if that was not right.
8. Yeah, just about there. 8. Try 1 divided by 4. 0.25.
Here's 0.2, should go in the middle.
Were you right? OK, put yourself in. Where are you going to go? Oh, I've got yours. OK. She's blocked you off a bit there, Adam, hasn't she? Yeah. Right. You can still get there. Oh, how do you know? What sort of fraction have you got to get? 0.7. OK, put it in. He's got 3 in a row, Adele. Oh, you're going to have to think of blocking him off a bit better to have another game. Looking back on my main part of the lesson, I think my lower ability children need a bit more work on placing numbers on a number line, but my upper ability and my middle ability children really understood what was expected from them, and as a consequence they were able to place lots of crosses on the number line and in turn find harder decimals to place on the number line. In the plenary, what I aim to do is to recap on what the children have done in the main part of the activity. And I'm going to do this by asking them what strategies they use to get 3 crosses in a line. Right, children, now let's think about what we've learnt today. Which numbers were really hard to place on your number line? Sarah?
Recurrence numbers.
What do you mean by recurrent numbers?
Where they go on and on. And they
Recurring numbers. Recurring numbers. Well done. What did you have a problem with then?
0.88888.
And why did you find that hard to place on your number line?
Because we only had 0.8 and it was quite hard.
Rochelle, you've got something to add to that?
In the middle of 0.8 and 0.9.
Have a look at that number now. I want you to think. Sarah just said that was a recurring number, 0.8888. I'm going to put it on the blackboard and I want you to tell me, what do you think it was nearest to, 0.8 or 0.9, and why? Have a look at it. Emma. 0.9. Why do you think it's nearer 0.9 than 0.8?
The 8's after it, they're closer to 9 than 8. Well, they're closer to the nearest 10 than the number.
Well done. So what are you doing in your head?
Rounding up.
You're rounding it up. Emma said, well, that's really nearly 0.9, but I know 9/10 is 0.9. So if I can't round it up to 1 decimal place, what can I round it up to? Michaela?
Could you round it up? Not the first one. Keep the first decimal place as 8. And then on the second one, round the rest of the numbers up to 9.
So what are you telling me? Round it up to the... How many decimal places?
2.
To 2 decimal places. Instead of rounding up to 1 decimal place, we ought to round it up to 2. All right. So we're looking at this bit. Instead of 0.88, what is that now? Stuart.
0.89.
That one rounds up this number. So that's not 0.8 anymore. 0.89. So you solved that one. Sarah, you said, well, when we get recurring numbers, they're really hard to place on the number line. So what we have to do with recurring numbers is round them up or down. Right, that's one thing we've learnt today. How did you beat your opponent? What strategies did you use? David?
I looked at what my opponent was typing in and saw their answer, and then if it was near to one that I had to put in, I would put something like theirs in.
Say Emma here had typed in 9/8. What would you type in? You had to think of a fraction near to Emma's. OK, so what did you type in?
9/10. 9/7.
So you typed in 9/7. So the strategy you used, David, was to think of a fraction near to your opponent's. A good strategy. Any other strategies that we used today? You had to find a number that went between that point and that point. How would you find one? What are you trying to... Somebody help them out. What are they trying to think of? Stuart.
They were trying to think of something bigger than a quarter but smaller than a half.
All right, and what fraction do you know is bigger than a quarter but smaller than a half?
A third.
A third. So not only did you have to use David's strategy, try and think of fractions near to your opponents, you also had to think about fractions that were smaller than or larger than. Well done. And we've learnt about recurring numbers. Have we achieved our objectives today? Have we found decimals that are equivalent to fractions? Right. Homework now, children, for tonight. I want you all tonight to go home and have a look at your free paper. I know you get it tonight. And I want you to have a look for these sorts of things. Can you read that out for me, Keely? What's it say?
50%.
50%
Of.
What else might you see?
25% reduced.
Reduced. Excellent. Good girl. Reduced. What other words might we see?
Discount.
Discount. Excellent. And tomorrow what we're going to do is I'm going to show you how to use the calculator to solve these percentages problems. What I'd like to do next from this is actually link this work in with percentages, which was my homework that I set them.